good morning, and thanks very much for coming at this early time of the day. We certainly appreciate that. It's early for us too.
Yeah, sleep is nice. Apparently, I don't like it enough.
All right, you wanna go?
Sure. Yeah, again, hi, everyone who just also came in the room after he said that. Yeah, so if you aren't here for distributed patterns compared, either yay, thanks, stay anyway, or you did something wrong. So yeah, we're going to be talking about some different frameworks, Kubernetes, service meshes, and eBPF. So I am a developer advocate over at VMware. I'm in Seattle or wherever, such as here. That for those who still use Twitter, because some people do, there's my Twitter. And we have Matthias here.
Yes, yeah, good morning again. My name is Matthias. I'm not working for VMware. I'm working for a company called Novatech in Germany. We do custom software development and technology consulting in the cloud native space. And as a side role of that, I'm also teaching at 2 universities in the area of distributed systems. And this was kind of the fundament for pulling this talk together. All right.
Okay, so this is kind of like a little high-level view of the things that we're going to be talking about. Right now, the slide just says Spring Cloud because this was originally created by Matthias for Spring I/O in Barcelona. If you're going to be at the next one, which is next week, hope to see you all there. But obviously, the world isn't just Spring. So there's more other things there as well. So just doing a little polling of the audience. Who has used something in the top left corner there? All right. Okay. Who has used Kubernetes? More people. Okay. Service mesh. Okay, getting a little smaller. And eBPF.
Okay.
2 hands. Sweet. Awesome.
One more question. Who was at my other talk yesterday about observability? Oh, that's good. Well, a few. Okay. So there might be, like, especially in the introduction parts of service mesh and eBPF, there might be a short overlap. But apart from that, this one is less about observability and more about implementation of distributed systems in general.
And then you don't have to do that part again, because I'm doing that part, so it's all fine, right?
All right, good. All right, so basically the way we're going to split it is that I'm going to do a bit of the introduction kind of thing and outline the scenarios for distributed systems and the problems associated with that in general, and then cover all the framework kind of part. And Tiffany will then do the Kubernetes service mesh and eBPF, and in the end we're going to come hopefully to a certain kind of conclusion about the things out there, and maybe also have time to demo a little bit, but that depends really on how things go. So, yeah, also one of the good things at this DevOps is like it's a bit more of a cozy, familiar atmosphere. It's not like these big cinema rooms and then as other ones. So this is easier to interact with people. So if you should have any kind of questions or whatever throughout this talk, please feel free to interrupt us and step in. And we're happy to explain if this fits in at the point. Otherwise, we can still put it towards the end. All right, so yeah, why would people actually come to the idea of doing such a thing as a distributed architecture? Because just by the name of it, that already sounds like something which is more complicated than a non-distributed architecture. In the end, most likely it will be to serve clients. I mean, normally if we do software, we write software for clients. So for the clients, even a distributed system should in the end appear as one single system. I mean, if you log on to Google, you don't worry about like how many containers they would run in the background or whatsoever. You just consume the service. And the service provider, it's the responsibility to provide that service in an efficient way. And sometimes distributed systems or distributed architecture can be a reason to do that, like a way to do that. So things why you might want to do it is like the first category of reasons I would put under the umbrella of heterogeneity, like running different things in a way, for example, that we say we're running multiple tasks or processes. We might even want to run them in parallel and so on. So this could be one of the reasons why you would want to do that. Other ones would be more about the underlying infrastructure. So you might have different operating systems like Unix, mainframe, Linux, Windows, whatsoever. Or on a higher level, just using different frameworks and technologies. I mean, this is a sample like many of us might have seen with polyglot kind of microservices. You are now able to implement, you like basically pick the right tool for the right job. So you might use a different technology for the front end parts and then other things for the back end, message processing, and so on. And with a distributed architecture, you can basically put them all together and make this all work. And even if you're not using so many polyglot things, if you're just within a certain framework or within a certain language, there might be version differences which kind of force you to actually run things in a distributed manner. This one is more on the not so much on the technical side, but more on the people side. And the fun thing is like this was not part of my original slide deck, but this was actually a feedback that I got from one of my students. And he said, wouldn't it also be a thing that if you have multiple autonomous development teams and they basically build a certain component, that leads to a certain factor of distribution? And he was absolutely right. So I added this, and we also tried to hire him. So he's thinking pretty far ahead. I was really impressed by that. Now, and the next thing is, of course, extensibility. So if you already have a system and you want to grow it over time and basically add functionality, you may not want to like rebuild and repackage and restart everything from scratch when you want to add a certain component to that. So these are the things, as I said, under the category of heterogeneous environments. The other part or the other reason is more under the aspect of resilience and robustness. So distribution can also be a thing to say, instead of one instance of an application, I'm running 4. And so if one instance goes down, then my clients could still be happily served with the other 3. Or that I distribute the load across the instances. So if my user base increases and I don't want to get my systems overloaded, then I can certainly say, okay, I want to have more instances there and do some load balancing. Or if the clients get even more, or it could potentially also go under the thing of like a denial of service attack, then I might want to have a distributed architecture that actually blocks the traffic and protects the system. So to say, I have things like a circuit breaker or a bulkhead or whatever to say, okay, rather than all my systems going down now, I control, on a controlled level, I push back the traffic and re-allow it once it's either less or I have scaled up to more instances. Subform of that would be throttling the traffic to say, okay, I'm only going to let the traffic through in a way how my systems can handle that. Security is, of course, a thing to say, okay, I want to filter those requests that are actually allowed to my end systems in a certain kind of a proxy or API gateway. And also updates. So, of course, I want my system always to be running with hopefully no downtime. And with a certain level of distribution, I can say I'm deploying a new version while the old one is still running, and I'm switching the traffic on the fly, and the end users hopefully wouldn't even notice it. A subform of that is what people call canary deployment, where you say, okay, I'm doing the same thing as I had before, but I'm not switching the entire traffic over at one step. But I start rolling out a new feature, and then I put some dedicated traffic on that new one. That can be based on percentage values, but it could also be like in the request headers where you say, like Facebook does that thing sometimes often that they roll out new features only to certain regions, and then they're having both versions running in parallel. And if you're from a certain region, you'll access the new one. If it works fine, they roll it out to other ones as well. So there are probably more, but we only have 50 minutes. But anyway, this was just like a high-level intro of the reasons that you could have for taking that approach. Now, what do you need to do that? I mean, I've mentioned the network already very often. I mean, everything will come down to the network if you have distribution. So it's pretty obvious that the things need to talk in the same language. Next to talking, they also need to find each other. So you need something like a telephone book or a service registry where services can like register themselves when they start, and then other services can look them up and communicate with them. For error analysis, no, this is not error. For configuration, it's also helpful that you have mechanisms to roll out configurations to either all or multiple dedicated components of your distributed systems at a certain time. And I was already mentioning troubleshooting. Of course, you would also want to know what's going on. And when your system is totally distributed, this becomes even more of a task. So yeah, it kind of comes back to a certain network level that you have to inject components in the network at some stage that will take care of the traffic and do things like either blocking the traffic or routing the traffic to a certain destination, distribute it in terms of load balancing, throttling it, or what is not listed here, also observing what's going on. So I kind of sketched out this sample here, so how things could look like. We have 4 different services. We have like an API gateway, and we have components for service registry, configuration, observability. And as you can already see from all those connections in there, even with only 4 services, things can get quite complicated with that already. So kind of design this well. But then you are, of course, able to do those things I was talking about before. So you can potentially roll out a new version of an application while the other one is still running. You can scale up your instances. You can do load balancing and all that and make your application more resilient. And of course, all of those components could be of totally an independent type of underlying architecture. Now, if we go a bit back in time, and I'm switching over to the software frameworks, like one company that had this scenario, that they had to scale a lot and distribute a lot and roll out new versions and hopefully have no downtime whatsoever, was Netflix, because I think those clients, they wouldn't want to wait when they watch their movies. So Netflix had kind of chose an architecture, and I think it was back in 2015, where they built an open source framework building out many of those individual components to achieve those tasks. So for example, there was Zool as an API gateway, Ribbon for load balancing, and so on. So I'm not going to read through all of those. But what it basically comes down to, if we think about that component here again, you would have this component in various forms in there. So like, for example, the API gateway could take care of routing. Then there's the distribution for load balancing. Hystrix was basically to do resilience mechanism, blocking or throttling the traffic, and so on. So this was an approach to basically build dedicated implementations for the various components in your system. Spring Cloud took a pretty similar approach. Actually, I think they collaborated quite a bit there, and the Spring Cloud library was actually using also similar names and building on top of that. So Eureka was still there, Zool, Hystrix, and so on. Over time, it was replaced with Spring Cloud Gateway, or Resilience 4J kind of took the place of Hystrix a little bit. Anyway, within Spring Cloud, you had all those components in there to achieve the tasks that I had mentioned before. The way, and this is basically the first type of implementation that we're going to show. So the way that normally works, for those familiar with Spring, is like you add the dependency. In this case, I'm talking about Eureka, like the service registry. You don't have to do much. You add the dependency in there, and then you get an annotation for enable the Eureka server, and then you got that component running. On the other side, if you are like a client, you have to add another dependency, and then this client will register at Eureka whenever it starts. And other components can find it then. So it's kind of always a bit of a mixture of a dependency, code, and configuration change. Not much, but of course, an implementation change. Here we have a sample for the Spring Cloud Gateway. This one, as I said, performs mostly like routing tasks. So if you say some request is coming in, then I want to forward it to that component. So I don't want to go through all of those, just basically showing what the concept of it is and also the advantages. So basically, this means all these implementations are running as part of the process. So that means potentially they could all be running on one big machine and still communicate over the network. but they could also run on all individual machines across the network. They could be run in containers. This is very popular nowadays. Anyway, technically, they're just totally independent of the underlying infrastructure. So the future things we're going to see in this presentation will mostly have Kubernetes as a prerequisite. This one does not. I mean, this one, if you don't do Kubernetes, you can use this framework and run it wherever you like. So it has code changes, but it makes it independent of the infrastructure. Now, as Tiffany already said, I definitely have a lot more Spring background than Micronaut and Quarkus, but still, I got that feedback on this slide deck after a while to say, why don't you add some other frameworks as well? And so I kind of added those slides. So basically, if you build a Micronaut or a Quarkus application, it's a very similar way. You have the dependencies, you have the configuration, and so on. So for Micronaut, you can still use the Netflix open source libraries. They would be basically working in the same way. You could also do, so you have to discover Eureka and the next Netflix Haeussler component for configuration. Alternatively, you could also use HashiCorp console to achieve the registry and configuration tasks. So the offer, let's say, is not as big as in around Spring Cloud, but you certainly can get the job done and build your Micronaut applications just as such. Quarkus takes a bit of a different approach there. They're using an external library or framework called SmallRye. SmallRye is actually also being used by other Java frameworks like Wildfly, OpenLiberty, and MicroProfile. I think this is where it initially comes from. And this is actually very similar to Spring Cloud because it provides services for service discovery, configuration, fault tolerance, and such. So all in all, no matter which framework you use, you are able to build a system in that way. So to sum things up, the characteristics of all those are, the changes here are on an application level. You can really pick and choose and say, this one needs a certain kind of load balancing implementation. Here I need some resilience, here I need configuration, and so on. And for those that don't need it, basically you can leave it out, and you can kind of define the footprint of that change by yourself. So it works as a combination of dependencies, code and configuration, and it's independent of the underlying framework. So you could do all that and run the things like in Kubernetes, for example, but you could also run it completely standalone. So this is probably the big advantage there. And this lightweight thing is kind of what I already mentioned. All right, so that brings me to the end of the part for the frameworks. And I mentioned before that with Quarkus and Micronaut, probably the offer that you're going to get might not be as big as around Spring Cloud and what Netflix originally provided. And well, there are probably two reasons. One might be that they're a lot younger. So of course, to be fair, they didn't have the time to implement all that. But I think it's more like another reason. The thing is that Micronaut and Quarkus were built after Kubernetes already existed. So we will see in a second that Kubernetes already provides some of those functionality out of the box. And especially a framework like Quarkus, who claims to be Kubernetes native and oriented towards Kubernetes, will then certainly start leveraging the things out of Kubernetes instead of building it into their own component. So with that, I'm going to hand over to Tiffany for an introduction into the distributed features of Kubernetes.
Yeah, so as I did actually, since more people have slowly trickled in, I want to ask again, who here has used Kubernetes?
Okay, that's good.
Thanks. Thank you very much. Yeah, so some of this stuff might be a little familiar in the very beginning, at least. So this is a similar diagram to what we were just looking at, but now in terms of actually Kubernetes. Basically, the idea of what we were doing before still works when you're using Kubernetes. And for the few folks who haven't used Kubernetes or maybe don't even know much about Kubernetes, you can kind of imagine it as basically like a container daemon that's across multiple nodes instead of just one. So if you think back to the slide with the cute little Docker whale at the bottom there. One of the differences, though, is that the base unit is not actually a container. It is this thing called a pod, which you can effectively think of it being just like a wrapper around a container. or that could also have multiple containers in that, which we'll get into a little bit later. But yeah, it's basically smallest unit of deployment. So though there's been a bunch of like Spring logos and comments about Spring Boot and stuff, obviously Kubernetes wasn't just written for Spring Boot. It was created for running distributed applications. So out of the box, there are several API objects. Well, several is an understatement. There's a lot of them. So there's things like you can have deployments, can have services, there's replica sets. So like a deployment, for instance, it's used for managing a replica set. So say if you have a new image, you can do things like with graceful migration, you can scale up with your replica set being like, hey, I want 3, 2, whatever number of copies of my pod running. And then you have ingress there that you're dealing with inbound traffic and routing. And there's more stuff. So with the service registry that comes there by default, you don't have to go and like deal with your own. There's things with config maps and secrets for dealing with like external configuration. And like, as I just had mentioned with ingress, we have that for inbound traffic. And all these things pretty much that we were just looking at and fill in some of the components of what we were talking about, or what Matthias was talking about a little bit earlier. And since these come out of the box, you don't have to be like, hey, I need to build this into my application. You can just worry about your application. And then since these applications, they run inside of containers, then you can be like, hey, I want to write it in Java, or I want to write it in Go, or whatever language that you decide you want to be able to do with that. So I'm not going to go into every single one of those components because that's not what this talk is for, and I have 29 minutes left. So yeah, services are one of the pretty useful things for distributed systems. So Kubernetes services, basically, they fulfill like 2 main purposes. So one is registering itself inside of the Kubernetes service registry with some sort of name that it has there. And like for this one here, the name is visit service. And then with that name, it can be looked up and found in there. And then the other one is that there is load balancing done between the different instances of the pod that are associated with that service via the label selector. So for instance, here you have 3 replicas, so then it'll be between those 3. So yeah, basically there's just like several things that to recap that come out of the box. So like service registry, discovery, replication, and load balancing just out of the box. So we also have things with config maps and secrets. And if you have used Kubernetes, you're probably very familiar that there's a ton of YAML around. So yay, more YAML. But yeah, basically, there isn't a configuration server that's there. Instead, you have the config maps and secrets. And they're basically used for additional configuration that can be injected in some sort of like 12-factor style. So there's a bunch of these things that Kubernetes has like out of the box again. So there's like scaling, load balancing, service registry, external configuration. But there are some things that Kubernetes by default lacks. So some of those things are like being able to react to things on the network, since there are no like built-in resilience patterns in Kubernetes where things can happen like blocking or throttling or securing traffic. And you can't be like, hey, I want the traffic to be routed in some specific way there. So there's that kind of thing. But luckily, there are things that are created out there to help fill in this gap. So one of these is service mesh. So as I kind of mentioned on the first Kubernetes slide, so basically the base unit is a pod, and it is a wrapper around at least this container, or a container, basically. And then, so as a result, basically this pod, and therefore the containers that are inside of this pod, are connected to the network traffic. Pods can also have multiple containers in them, which I have this silly analogy for this. If you think about like Docker, and Docker is a whale, and a group of whales is a pod, so group of container whales, I don't know. Whatever. Okay, somebody laughed. It's not that terrible. Okay. Or maybe it is that terrible. Anyway, so these multiple pods that are sitting within, or these multiple containers sitting within a pod, they all share the same network address. So the traffic that one container can see, the other one can see as well. So it generally doesn't make too much sense to have two like application containers running inside of the same pod. What does make sense, though, is to instead have, here's my application, and then I'm going to also have some sort of like proxy there so that can listen to the traffic that's coming through. So if you only had it for like this one here, and that's all you have for your entire cluster, I mean, if this is your only pod on your entire cluster, okay, I guess that's fine, but you probably have more, and if you do, you then would want to be doing this for every single application that you have running. Basically, you end up injecting this proxy into every single pod that you have there, and then therefore you have like information on the entire network flow of your cluster that gets aggregated into the control plane. Basically, the data plane up there is where it does collection and then goes down over into the control plane. And then based on that, you can be like, hey, I want to do X things with it. And you can also do things such as like applying policies and rules to direct the traffic that you have there. So it can be independent, basically whatever language or framework that you want to use. So you can literally run whatever app that you want to run on Kubernetes with this. It seriously doesn't matter. It's just disconnected. You don't have to worry about being like, hey, I need to go manually restart my application, or oh no, I have to rebuild my application. You just add a proxy, and Kubernetes handles the rest with things like that, which makes it a lot easier and way more accessible. You could decide, hey, I tried this, there's too much latency, or this is just too much work and I don't want this, or it doesn't fill the needs that I have. So I'm just gonna go remove it. And again, you don't have to rebuild your applications. They're just fine. You just pull out the proxy and you're good. And so yeah, basically all the stuff that you have from every single one of these different applications all gets collected and goes into your control plane. So just to reiterate, looking at this again, this is what Kubernetes looks like without a service mesh. So let's see. What?
No, all good.
Okay, and then if we're looking over on here, basically you can see like just in general with how things are communicating. Let's see. Yeah, so here, if we look back here, here's your original pods, and then now you see that your pods are basically expanding, and then every single one of these ends up getting its own proxy. So you don't end up putting just a proxy in every single application. You end up putting a proxy in every single like instance. So like if you have 3 copies of, like you have a deployment and there's 3 copies, every single one of those has to have a proxy in it as well. And that can add like a lot of overhead. So, I mean, this diagram just keeps becoming more and more. So yeah, all this stuff goes over into this control plane. To me, it looks basically like just some crazy like octopus with legs at this point. So that's kind of why some people, instead of just calling it service mesh, call it service mess, because, I mean, look at this. But yeah. But basically, with that comes a bunch of great things. So like now you basically can have granular control over like individual components because of each proxy. And then you can do things like encrypting or securing traffic like between, say, these 2 components that we have here. So more YAML. So you have CRDs, which are custom resource definitions, and you use that to model it. I mean, if you haven't dealt with CRDs, this still looks pretty familiar with any other resource. Maybe it's a pod or a deployment or whatever, but the kind is different and the things that you have in there are different. So this specific one here is basically saying that traffic can be allowed to go to a specific place if it matches a specific source label. So you can see with the little circle around source labels, it's looking for something with like app B. And there's like various ways to like build the rules for that. You can also do things like encryption. And since, yeah, this is just basically an extension of Kubernetes, it's just YAML. So out of the box, Kubernetes supports some sort of like graceful migration from one version to another. But out of the box, you can't do things like splitting by percentage. So like here, for instance, 66 and 33. Like at the most, it's like, hey, if you wanted to do it that way, you'd have to have like 3 pods or something. Like it's only splitting evenly between the number of pods that you have out of the box. Or if you want to be able to do things like listening to something on the network, you can't go and do that. So service mesh basically goes and adds this. So, and with the splitting, one of the nice things is it's not like, hey, I decided I'm going to do 66, I'm going to do 33, and well, now I'm stuck. You can actually change what it is without just restarting everything. It's kind of like a similar concept to like with network policy, where you can granularly decide like about the routing between like the different things that you have there. So for this example here, we have the 2 destinations that we have there. And then we can see that we are giving a weight here of 75 for one and 25 the other. So basically splitting the traffic by 75 and 25% there. And then again, like you can dynamically go and like change this configuration and it'll be able to pick that up. And you can change the way it's being routed without changing anything with your application. Like this whole thing has nothing to do with whatever random application, whether you're running Nginx or anything, your own application, it doesn't matter at all. So this is kind of like a bunch of like if you're dealing specifically with like, instead of it being with all the pod stuff and dealing specifically with ingress, this is basically a bunch of the things that you can end up actually doing with your traffic. So you can do things like with like fault injection and do things like simulating network outages and dealing with latency and just kind of seeing, hey, how does my application react based on this? You can do things with like circuit breaking, retries, and policy enforcement, etc. So yeah, going back here a little bit, like this is just like another like view of being able to actually get visibility into your cluster. So like it says percentage routing, but more specifically, this one is for observability. The control plane can kind of see everything that it's getting from your cluster can kind of see what is happening over in here. So since it can see everything that is happening here, now with all this valuable information, there's actually a way to go and visualize it due to just all the things with observability that it adds. Since it's not just, hey, I'm doing this specific stuff with networking, but now I can actually see. So this is a tool called K8s. It's specifically for being able to do these types of things with service meshes. And you can also see this cool thing where you actually can see the direction that the traffic is flowing. So right now, for instance, there are 2 pods there, but it's routing 100% of the traffic through one of the 2 versions, and that's it. And yeah, just like this kind of thing is super helpful if you're like wondering, hey, something's happening, but now you can see, oh, and it never talked to that pod in the first place. And then you can see when traffic splitting is happening. So now you can see there's the 86 point something and the 13.1. So I guess 86.9. So yeah, you can see how that ends up going. So who here has heard of the like I guess demo app in a way of Spring Pet Clinic? Okay, few people. Basically, it's a really cute little veterinarian thing. Has a cute little cat and puppy, and you can have. There's different services in there. They're like, who are the customers? Who are the veterinarians? What are the pets? So this is just kind of like a example thing for that. So this is the corresponding output of what this looks like on K8s. And so you can see like over on the left, we have the API gateway, and then we have those various services. You can see arrow directions and stuff. And if this was animated and there was traffic, you could actually see things moving, which is pretty cool. So we've been looking at like a bunch of the super awesome things about service mesh, but with most things, not everything is awesome. There's usually some buts in there. So let's look a little bit at the other side of things. So one of the things is by the fact that you're adding a proxy inside of every single pod that you have, that adds overhead. So that adds more CPU, that adds more memory, that also adds more latency because you have a bunch of additional like network hops. And so the CNCF basically did a benchmark with 2 of the really big service mesh products of Linkerd and Istio. This was in 2021. So yeah, you can kind of see like what the baseline is versus like what has been added there. So it's definitely something that you should be looking into. And again, if you decide, hey, oh, wow, that's too much, I can't do that, then you can take out the proxies. So to kind of recap things a little bit. So service mesh basically, yeah, it extends Kubernetes for the things that are kind of missing or limited that are there in the respect to like traffic awareness and shaping. It's the concept of you end up having like your proxy, which is a sidecar that you have sitting in every single one of your pods, so that you can therefore see what's going on with your network flow for the entire cluster. It does not have application level metrics, so you can't be like, hey, what is happening when I do this one specific call in my code? It doesn't do that. And then you can also make changes at runtime, so like what I was mentioning with the percentage changes and whatnot. So this brings us to eBPF, which had the least number of hands because it's newer. I assume at least that's why, but it's one of the things I keep hearing about a lot. It also has a really cute logo, so that's cool. So it stands for the Extended Berkeley Packet Filter, which if someone just read this to you, not in like communication about distributed systems or this talk, I'd be like, what is that? Like, I just think about like the university or something, and I don't know. But let's kind of go into it a bit. So it's pretty like low level. So you have, say, your kernel space over there, and then your user space over here. So like generally speaking, the kernel space is where the kernel software runs. It's usually quite protected. And it's pretty difficult to change. So for instance, if you are trying to there's something that you specifically want to change in like Linux or whatever, and you make some PR and stuff, I mean, depending on what you did, the amount of time that it takes for that to actually be part of the next version might be the amount of time it takes for a new royalty in the UK. I don't know. But yeah, so the things that you normally like interact with are the things that are over in the user space. So like one comparable way is thinking about it is like JavaScript in a web page to what the eBPF sandbox is in the kernel. Like you can run custom code, but you don't have to worry about like harming the environment that's there. And so in the kernel space, it can interact with kernel events such as network events. And then it ends up sending things over to the user space where it actually does more of the handling of things. It can do processing with things like SDKs, with libraries, with tools, and actually like dealing with it over there. So as a kind of more overview thing back with Kubernetes, yeah, basically Kubernetes, it runs on nodes. And on top of that, you end up having these containers. And then on the bottom, you have an operating system, which usually, or at least often enough for now, is Linux, with our lovely penguin here, Tux. But yeah, since eBPF stuff is specifically dealing with Linux, and our nodes are specifically dealing with Linux, you can basically use eBPF on any worker node that you have in your cluster that is using Linux. So it's kind of similar in a way to the like pod-based service mesh that we were just looking at, where you have like your proxy in each one. So instead of having your proxy in every single one of your pods, now we're going to the node level of things. So you can see, hey, here's my 3 nodes. So then I have one for each node. That's on your data plane. And then your control plane, again, is what is dealing with aggregating that information. And based on that, you can decide what you want to do with it. And one would assume that if you're doing anything at high scale, that you probably have more pods than you have nodes. If you don't, that I don't know what like I don't know what you're doing. But yeah. So yeah, looking at this again, this is just what it looked like beforehand. And so now it's a little less chaotic looking because you just have your nodes, and then those are talking to the control plane versus that squiggle to every single one of those. So you can do some pretty similar things. Again, yay YAML, one of Josh Long's favorite things in the world. So you can do things like applying network policies. Like there's like the same thing with the other ones, there's different selectors that you can use for deciding what you want. You can do it for like routing traffic from like one component to another, and you can overall just end up getting control over your entire cluster that you have there. So Cilium did this survey about what features of Service Mesh interest you the most. So there's a bunch of things here that you probably remember from our previous slides. So things like canary rollouts, ingress, rate limiting, circuit breaking, etc. But maybe a little bit surprisingly, actually, the thing that the people cared about the most is observability. So with that, with Cilium, you can, kind of like how we were looking at with Kali a little bit ago, you can actually see everything here. I really like that. It looks like a plane, so that's cool. But and you can end up seeing how the traffic flows and basically what's happening there. So yeah, as another like overview thing, basically you insert the proxy component on the node instead of on a pod level. It uses like Linux low-level functionality because we're using that, but it's specifically being leveraged for Kubernetes. Since you have fewer hops, since there are fewer proxies going there, there's lower latency. Cilium is still a fairly younger product, at least compared to some of the other things that we've been looking at, but it's gaining a lot of traction. I keep hearing about it over and over. And it covers things with not just networking, but also security and observability as well.
All right, so thanks. So we're like almost coming towards an end here. I mean, you have seen now various ways of approaching the things to get those tasks being implemented. You saw things on a framework level where you would put the implementation specifically into your various components. Then you saw how Kubernetes came onto the stage and taking a couple of things or bringing a couple of things out of the box, which of course also made some things here obsolete. So some things we did not show in this presentation today. So if you had been using, for example, Eureka as a service registry before, and then you switch to Kubernetes, you obviously don't need to have two different service registries. That wouldn't make much sense. So there's also a project called Spring Cloud Kubernetes, which would basically leave you with your original code, the way you accessed Eureka in the first place, but then instead of going to a Eureka implementation, it would use the service registry of Kubernetes. So there's an easy transition to go into that direction. Anyway, yeah, we've seen what Kubernetes can do for you, and also where Kubernetes might have its limitations. So comparing it back to Spring Cloud, so something like Resilience 4J or Hystrix, this is something which is not possible with Kubernetes out of the box. So for that, the service meshes with or without sidecars is basically helping you to bridge that gap to getting control and insight over the network. Now, what does that mean all for you? We're not here to make a recommendation and say, well, this is the right one and this is the bad one. It actually, the basic recommendation for especially the service mesh things, try out Istio, try out Linkerd, try out Cilium. They are all open source. They're easy to set up. And you quickly kind of get the point of what you can do with it, and then you can decide what is best for you. I mean, obviously, it might not make sense to use Cilium and Istio in the same environment, even though there are migration scenarios happening at the moment where this is a supported way. But you don't need to monitor, put the proxies into the pods and put the proxies into the nodes. That would not make your system a lot faster. So this combination I would potentially exclude. And other than that, of course, combining some things from a framework with something in Kubernetes might make sense to say, okay, Tiffany has mentioned the config server versus the config maps or secrets in Kubernetes. With a config server, you can certainly do more things than with just plain config maps. And of course, it's just a valid scenario to use Kubernetes to get all those features and then place the config server as an element in there for the distributed configuration within the cluster. That works absolutely fine. All right. So yeah, there is no. We didn't do this to like pick a winner. In the end, I hope you all are going to be the winners of that because there are options in various ways of how you can do things. And I think especially this eBPF development will bring a lot of new energy into all of that, because I mean there was clearly a place for service meshes in the first place because there were some situations that was just not resolvable with plain Kubernetes. But then on the end, the sidecar overhead was definitely a problem to a lot of people that adopted it. I mean, in the end, it meant to you that you not only have, when you update something, I mean, if you update Kubernetes, that doesn't mean automatically your service mesh will update along. So it was basically another layer of architecture that you had to manage by yourself. This gets certainly better, and it does not affect the application so much if you do things on a node. Also, one side I don't have in here at the moment is this already had some effects on the Istio service mesh. So last year, they also come out with something which was called the Istio ambient mesh, which is also like a sidecar-free service mesh implementation. So as I said, it opens up new possibilities, and we're certainly not at the end of the road yet. Hopefully, it's going to get a little simpler for us. It probably will still mean we have to deal with YAML. I mean, you can use JSON, but it doesn't make things a lot better, I think. Anyway, yeah, and also from what we've learned at KubeCon recently, that eBPF components are now also trying to connect pieces outside of the Kubernetes cluster, so it might not be 100% Kubernetes required anymore. And yeah, so I hope we could give you a bit of an insight into all those things. And with that, we would like to say thank you very much for listening. And yeah, two more things. I saw people taking photos throughout the talk. This is the slide deck. If you want, you have the overall slides for download. And yeah, I've given this talk last week at DevFox Greece as well. And one of the other speakers approached me after that talk and said, if I did all those graphics by hand, and the answer is yes, I did all these graphics by hand. There's a tool for that, which is called Excalibur. Oh, you can't see that. Hang on. How do I jump out of this?
Just jump out of mirroring.
Jump out of
turn it to mirror.
So all right. So this is that tool. It's a web-based tool, so you can basically sketch and do all the things right in your browser. I basically discovered this when I was teaching university lectures through the pandemic. The thing I was missing dearly was like a blackboard, like to write down things and help explaining it. So here, this is actually a sketch out of the university lecture where I like outlined the concepts of Kubernetes here. And yeah, so I just shout out to them. It's free. It's pretty cool, and as you have seen, also helpful for the presentations here. All right. Are there any questions? We have 3 minutes. Yes, please. Oh, there's a mic. Yeah.
Assuming you need some sort of service mesh or something like that, and you don't have one, would you go first with eBPF and then go to Istio or something like that? Considering what you said about, overhead and...
Well, I would probably try to evaluate and try both. I mean, if you just like spin up two kind of playground clusters, it's pretty easy to set things up and see what you're getting out of it. With Istio, it's like Istio and Kiali and all the things that we have seen here are 100% open source, and you can reuse it in that way. With Cilium, that main technology that's using the eBPF framework, they have like an open source part and also an enterprise part. So this is still something which I'm not familiar with entirely. Which of the things can you actually do free, and which of the things that you have to work with? This is also something, as I said, I hope this is kind of fueling that kind of development, and more things get out there if more people jump on that train. So yeah, I mean, I don't have a clear recommendation there, and it's still also this. I mean, you said before you probably need a service mesh. This is something what I would probably challenge in the first place. Because, I mean, we've shown a lot of options now, but that doesn't necessarily mean everyone needs that. I mean, I had Netflix as an example before. They probably need it, but I've seen people having like a 3-tier microservice application using a service mesh, and I said, what's the point? I mean, you might not need all the features in there, and this is also what we try to bring around with that talk. Is if you put that pod-based service mesh in, you get kind of like a full-blown API gateway in every of your pods, and you're going to pay for that in CPU and memory, and especially in network latency. So I wouldn't agree with you probably need it. I normally try to only add it when I really have that need. And something we didn't mention today is you do not have to do this all across your cluster. You can do it on a namespace level within Kubernetes. So I say this namespace I'm going to enable, this one I'm not. So this way you can still kind of maintain the balance. But in the end, yeah, try it out. I mean, both are pretty easy to set up, and I would give either one a shot and then see what works best for you. Hope this helps a little. All right, time's up, it says. If you have any more questions, we're going to be around here the next 2 days, so feel free to reach out to us.